Thank you, Suyong. It was great. Now, after moving to Hong Kong, we will move to North America on the West Coast and in the East Coast. So we will meet Mitch and Rajan. Another very hands-on session because the challenges they wanted to take is really to work without any slides, just CLIs and scripting. So see the new operators in action for Landscape, one of the products of Canonical, by our colleagues, Rajan and Mitch. And they will do a coding session with you. They will highlight how infrastructure as code migration can be done and basically to introduce some cloud-native transformation patterns. Thank you.
Thanks for the introduction, Cedric. I'm Rajan Patel, the product manager for Landscape, and I'm joined here by our lead engineer for Landscape, Mitch Burton. So shortly we'll go full screen and I'll install the Landscape Scalable Charm bundle using Juju, and you're welcome to share your questions as we go along. But at a high level, Juju charms are operators for deploying and managing applications in a cloud-native environment. And while some operators are focused on managing Kubernetes resources, Juju charms can manage a variety of resources beyond Kubernetes. Juju can deploy applications across multiple cloud providers and infrastructure technologies, including public clouds like AWS, Azure, and private clouds like OpenStack and even bare metal servers. Juju charms take into account dependencies and relationships between different applications and services, and this allows for more complex applications to be deployed and managed with ease. So Juju has evolved over the years, and our lead engineer for Landscape will walk you through refactoring a legacy Juju charm to one that uses the modern operator framework. Let's dive into the installation, and then I'll hand it over to Mitch. Let's go ahead and install Juju. Our prerequisites, this should take about 3 minutes. Go app install certbot because our Landscape Scalable deployment is going to need to be accessed over SSL. We'll get a SSL certificate through Let's Encrypt. Next, we'll snap install Juju. And because our virtual machine here is running on Google Public Cloud, the MTU is set to an exotic 1460. So this is a bit of a non-standard step, but if you have a custom MTU configuration, then you'll want to set your LXD containers to communicate over a network bridge that has that same MTU configuration. So I'll initialize LXD. Again, that is our optional step. And then I'll set the LXD bridge to all right. So it looks like we're all set here. We'll check. Our MTU is set correctly. Now that we've got our MTU set, we're going to go ahead and bootstrap our model. The command to do that is Juju bootstrap localhost. And we'll give the model a name. I'll call it LXD Landscape. Bootstrap. Not Buddhist in the strap. Spelling is hard today. But here we are. Now it's downloading the appropriate LXD image for the model controller. Some notes about running this: you would want to make sure that your IP table firewalls are turned off, otherwise this connection won't occur successfully. And it takes approximately 5 minutes for this step to complete. The subsequent step, where we deploy the actual Landscape Scalable Charm bundle, takes approximately 7 minutes. I'll deploy the Charm bundle and expect this process to take about 7 minutes. And to deploy the Edge channel, so you get the latest version of our code base. Fantastic. And fully deployed, you can see the configuration in action by using Juju status. So here it's waiting for a machine. It'll refresh every 5 seconds. I'll go ahead and Control C out of there and clear the screen. I'm going to turn this over to Mitch, and Mitch will walk you through refactoring the charms.
Thanks, Rajan. Hi, everyone. My name is Mitch Burton, and I'm a senior engineer on the landscape team at Canonical. Landscape, which we've been talking about a bit today, is, of course, Canonical's Ubuntu management and administration tool. It's provided both as software as a service and as a self-hosted package that can be installed by the user on their own hardware. Recently, we released a new version of Landscape Server, and a big part of our efforts there was providing new charmed operators so that Juju could be used to deploy Landscape Server in a straightforward, reproducible, and scalable way. This involved rewriting some charm code that was originally written using a kind of legacy charm framework, the hook-based approach. The hook-based approach is a way of formatting charm code such that when charm events, which happen throughout the life cycle of a charm, such as a relation being joined, configuration changing, or things like leadership changing, gets fired in a hook-based charm, there's individual files, executable files that match the name of that event and get executed when that event occurs. This way of structuring a charm is maybe a little bit too separated. You wind up with a bunch of different files, one for every single possible event, whereas the kind of new way of doing it, the operator framework way, or ops for short, is a way of writing a Juju charm in pure Python that allows you to a lot more flexibility in the way you structure your code. So in ops charm, you tend to have one main Python class, and then methods on that class are executed in response to events in Juju. To me, this seems a lot more flexible and a lot easier to kind of keep it all in your head. The complexity stays lower. Today I'll be taking one of the hooks that existed in our old landscape server charm, which uses a library called Charmhelpers, and is written in Python. And I'll be rewriting it using the ops framework approach, where it'll be a couple of methods in the main charm class, and it winds up being a lot smaller and a lot more straightforward. So let's get started there. Now, in a hook-based charm like I'm looking at here, the actual code that is executed by the charm is in this hooks directory. You can see in here there is a bunch of individual executable files, and their file names match the hooks that they are respond to. Essentially, when Juju emits the given event, such as DB relation changed, then this executable gets executed with the relation information. These ones, they can be written in whatever language you want. These ones written in Python. They use a library called Charmhelpers to interact with the relation data and other Juju fun stuff. The nice thing about that is because they're already written in Python, the ops framework is a Python library, so it makes it a little easier to convert them than if they're written in another language. And we can more or less kind of just translate the Python code from one format to another. So I'm going to start off by creating a new directory for landscape charm ops, and I will use charmcraft to initialize this directory as an ops-based charm. So what that gives you is just a few files to start with: metadata, config, the charm source code, and README. I'm going to switch my screen here for a second. We can get into editing this to kind of get us a framework for the start of writing the new charm. Okay, so I have ops source charm. So here we have the boilerplate that's created by by Charmcraft when you initialize a new charm. I'm going to mostly remove a lot of this because a lot of it is demonstration stuff that we don't need. So we'll delete these, all these methods here. Basically, all you need for an ops-based charm is a class that uses inherits charm base, and a main. So that's ops main that calls using that class. Unlike hook-based charms, ops charms can be entirely contained within one file if you want to. If you don't, you can modularize it into Python modules. Little kitty. Because ops is simply a Python library, you're free to structure it kind of however you want. The only requirement is that you have this file and you have this call to main right here. Another quick change we need to do is I need to update the metadata.yaml in the Charmcraft file to add, here I'll delete this unnecessary stuff at the bottom. We need to add a relation for the hook that we're going to be rewriting. So to do that, delete that stuff in the metadata, and then we go to config.yaml, and we add a, or sorry, not config, no, I'm wrong. It is in metadata.yaml. We add a requires B. So this is going to be a relation with a database with PostgreSQL. Interface is PGSQL. Might change the size when I save. It's a little weird. All right, back to the charm source code. And I'm also going to open up one of the hooks, and we'll start rewriting it. DB relation changed hook. So here we go. This is the DB relation changed hook. You see, like I mentioned earlier, this is just an executable file written in Python. It has a name equals main, instantiates this hook class, and calls it. What this hook does, there's a little bit of error handling, but majority of what it does is it uses a charm helpers class called service manager to hook up a provider, which gets data from the database relation. Provider gives data to the database relation. The require gets data from the database relation. And then once that data is ready, you have a callback here that writes the database configuration to a defined file. Pretty straightforward. The complexity here comes from needing hookenv and needing to write 3 different classes to do one straightforward thing. In ops framework, instead of doing something like this, you register your classes so that they you register methods on your classes. So for example, we do something like I'm gonna have to pause for a second. Let me restart a section here. I was supposed to have something else open, and now I'm throwing me off. Okay. So we start off by using the framework methods, register callbacks on specific Juju events. So in this case, we're doing DB relation joined and DB relation changed. We'll write these methods in a second. Relation changed. So we write a method, DB relation joined, for example, and that gets an event as an argument. And this one will take the place of the relation provider. So this provides data to the relation with the database once that relation has been created in Juju and we've joined it. So in order to do that, we need to look inside the event, which in the ops framework has a data bag. contains all of the data that's shared between the units. We're going to update it with this same information that we were doing in the hook-based charm. That's all we need to do to provide that information. Single line and a single method there. For the DB relation changed, this is where we're going to have to do most of the work, because when the relation changes, that means that the unit on the other side of the relation, or the application, Postgres in this case, has provided some data that we're going to need to use to write this configuration file like we do down here. So this is really the DB relation requirer becomes this method in the ops charm. Of course, it's still going to be a little bit simpler. So the first thing we need, if we look in here, there's two parts to this requirer. There's one where it says, is the data ready? And then there's one that actually gets the data out here. So first we need to check, is the data we're looking for actually available there? And we can do this pretty much exactly how it's written in the old charm. We get the unit data from the relation. That's the event.unit in this case. So it's the data provided by the unit on the other side of the relation event. And if this is straight out of the old code here, if the allowed units, so the units that are allowed to access the database, that key is not in our unit data, we're not ready. So we'll return early. This event will get fired again every time new data is added to the relation. So we can know that, returning early is not a problem. It will get executed again next time. So then, just like we did on the last one, we say, okay, let's get the allowed units out of there and check that this unit, which we get with ops framework, we just get from self.unit.name instead of having to go through hookenv. We got to check if that is in our allowed units. If it's not, we just return immediately, just like before. Last, we check if master is in unit data. So there, we're done replicating the is ready logic. Now that we're past that, we can do the actual get data logic here. So here we're getting a DSN string from the Postgres unit, and then we're parsing it to a dictionary, which we're then adding to the unit, then we're then updating the data with that and just writing it to file. Pretty straightforward. So in order to get that data, we'll have to probably write this parse DSN method, but that's fine. We can just copy that from the old one. Pretty easy. Sorry. There we go. So that's the same. So we can say that our DSN dictionary is parse the DSN of the unit data master, which we've already checked to make sure that that exists. And then we can also copy this writer. It's slightly, I'm sure. Add in there. We don't need any of this information. We just need the DSN info. We don't need to get the service name anymore. Yeah, we don't need any of this because we're not getting anything from the service anymore. We're just simply writing to a file. Very easy. We're going to write the database config with that DSN dictionary. And then, if we want to, we can do something fun like set the status of the unit to active. After that, with a little message like unit database is ready. I will need to import config parser. Okay, I think that's it. So just like that, we have changed our hook into just a couple of simple methods in our ops-based charm class. Done the complete interaction with the database to get the DSN information and added it to our config file within the charm. If you want, you can add a couple of other things here, like, when the relation changed, you can add a status change to maintenance status to say, getting DB, DSN data, so on and so forth. You just need to import that. So, we turned what was 3 classes and a lot of extra methods in our hook, though your hook might not be as complex as all that. It depends on how you originally wrote it, into just a couple of methods on a charms ops class. Do we have an ending for this?
Well, the next step would be, let's go ahead and get HA proxy.
Right, yeah,
and
HA proxy
port forwarded.
Yep, I can do that. Now that we've got Sorbonne set up, we can set up email sending in our landscape server. First step for doing that is to get the, let's take a look at the Juju status. Everything is installed, everything is active. Nice. We can we need the IP address of the HA proxy unit. Now, we could just copy paste it from here, but I'm going to do this using a command instead, just to show you can pull it out programmatically. So Juju run lets us execute something arbitrary on a unit. So we can do network get public. You could also probably parse the status of the unit. Ingress address true. Give that a second to execute on the proxy unit. Take a look to make sure we actually have it. We do, and it should match this one up here. It does. Nice. So then we want to read the IP address of our local machine here so that we can forward it. We can port forward appropriately. It's a little bit of awk magic. Okay, just make sure we got those. We do, nice. Okay, now we're going to do a little loop so that we can do this for both our HTTPS port and our regular HTTP port. So all I'm doing is setting up our IP tables so that we've got both of these ports. Oops. Add a comment so we know why we've done this. Cool. Let's do a little check on IP tables just to make sure things were set up appropriately. TCP, DNet, anywhere to. This looks fine. John, this looks fine, right?
Yes.
Seems correct to me. Yeah. Cool. So then we can set up, so we have an API key here. Should I be showing this? I got an API key that I'm going to copy here for sending emails via SendGrid. And we can now deploy a subordinate charm, the postfix relay charm. Now what this does is it associates with an existing charm and provides it with postfix configuration for sending email that charm can then use. Just add the all the correct SMTP authentication details, stealing Rajan's stuff here. Oh, SMTP. Okay, that'll deploy the subordinate charm with those configurations done. And then all we need to do is relate that, relate that subordinate charm with our landscape server charm, and then landscape server should be able to send outgoing email using those SendGrid credentials. Take a look here again at the status. Postfix is ready underneath landscape server. Landscape server is ready. Postfix is now in maintenance, and give it a little bit of time and it will appropriately set itself up after it's done installing. Could take a few minutes.
Yeah, it's worth noting that that subordinate charm is modifying the etc postfix main.cf file in the landscape server instance.
Right. Yeah, the subordinate charms work within the same container or VM or machine as the main charm does, so it has access to everything that's inside that main charm. There, it's done.
Fantastic. All right, so next, now that Mitch has got that all set up, I'm going to go ahead and log into the web-based dashboard, create the default global admin account for Landscape, and then invite Mitch using the appropriate part of the dashboard to invite additional administrators.
Invite an administrator, yeah. Hopefully I should get an email. Assuming we've set things up properly, I will receive an email. Or it'll go to spam.
All right. I'll go ahead and name here. So we're logged in. I'll go ahead and double check on the settings, make sure that the root URL is tracked. Operator day.
Set their correct system email address as well.
Yeah. And our SendGrid account here was set to send emails from my canonical email address. So we'll go ahead and hit save on that. Next, we'll go ahead and click on administrators. And this is where I can add an additional administrator. All right. Then you should have received an email on your side.
Yeah, we'll see how long that takes.
Once you accept it.
Yep. I did receive an email from you. Nice.
The unclaimed invitation will become a claimed invitation once you accept.
Yep. Accepting it now. I know. And I've accepted it.
Fantastic. And there we go. Mitch is now also a global admin in our Landscape Scalable install.
Cool. So all I had to do was add the subordinate term for postfix, and everything was set up appropriately.
Thanks very much for joining us on that adventure. And with that, we'll pass it back over to Cedric.
Thanks.